We ask it to write our emails, dream up amazing images, and answer questions we haven't even thought of yet. Artificial intelligence, it really does feel like magic. It's like this invisible brain just floating in the cloud, giving us whatever we want instantly. But what if I told you that behind that digital curtain, there's a very real and very resource-hungry physical world?
So when you type in a prompt and boof, an answer appears in seconds, have you ever really stopped to wonder where it comes from? Because I can promise you, it's not just appearing out of thin air.
Yeah, that whole cloud thing, it isn't actually in the sky. It's firmly on the ground, inside enormous, windowless data centers, packed to the gills with powerful, energy-guzzling servers. And to stop all that hardware from literally melting, they need to be cooled. And that cooling process devours two incredibly precious resources, electricity and fresh water. A lot of it.
All right, so let's pull back that curtain and really get a sense of the scale we're talking about here. Because the true environmental footprint of AI, well, it's pretty staggering. The numbers might actually surprise you.
So let's start with electricity. A simple Google search is something we do without thinking, right? Well, asking a similar question to a modern AI chatbot can use up to 10 times the amount of electricity. Now multiply that by the billions of queries that are happening every single day, and that energy demand it explodes. And then there's the water. Oh boy, the water. Some projections are estimating that by 2027, the global AI industry could require up to 6.6 billion cubic meters of water every year. Now, that's a hard number to wrap your head around, so try this. That's more water than the entire country of Denmark uses in a year.
To bring it down to a more personal level, researchers figure that for every 10 to 50 simple questions you ask a model like GPT-3, the data centers it lives in are essentially drinking a standard half-liter bottle of water just to keep the servers cool enough to answer you. Wild, right?
And here's a really crucial point. A lot of this water is consumed. That means it evaporates during the whole cooling process. It doesn't get cleaned and returned to the local river or lake. It's just gone from the local supply, which has a direct impact on the surrounding community and ecosystem. So here's the thing. This environmental cost isn't a flat rate. Not at all. The type of AI model you're using and the specific job you're asking it to do can change its resource footprint dramatically. Some AI is just much, much thirstier than others.
You can kind of break it down into two main camps. On one hand, you have these highly efficient, task-specific models, which are fine-tuned to do one thing really, really well. And then on the other hand, you have the big generative models that are so popular today. They are incredibly powerful, they're multi-talented, but all that general-purpose genius comes at a very steep energy cost. You can really see this difference plain as day when you look at the energy used for every 1,000 queries. A simple task like text classification, super efficient. But the moment you jump to a generative task, like creating a custom image from a text prompt, boom, the energy use just goes through the roof. I mean, just think about that for a second. A 16,000-fold difference in energy use between different AI tasks. The energy for that one inefficient image task is enough to charge your smartphone over 70 times. It's crystal clear. What we ask AI to do really, really matters.
Okay, so faced with these gigantic costs, what can we possibly do? Well, researchers are putting forward a solution that's surprisingly simple and frankly pretty elegant. It's an idea we're all already very familiar with from other parts of our daily lives.
This is it. This is the core idea. What if AI models had a simple energy rating, like an AI Energy Star label? Imagine a clear, easy-to-read system that shows the energy cost of using an AI model. It would empower literally everyone, from developers to end users, to make more sustainable choices. And look, this isn't just a pie-in-the-sky idea. It's totally possible. Take a look at these 3 different models. They're all a similar size, and they're all doing the exact same task. But the Yeast 6B model uses over 3 times more energy than the Almost 7B model to get the same job done. This kind of transparency could totally shift the market and push the whole industry to be more efficient.
Now, creating a more sustainable AI ecosystem isn't just about one single solution. It's really a shared responsibility that's going to require proactive steps from every single player in the game, from the research lab all the way to your laptop.
Researchers have pretty much laid out a 4-step roadmap. First, developers have to make measuring energy use a standard, non-negotiable practice. Second, companies, the ones who buy and deploy these models, they need to use their market power to demand more efficient models. Third, users, you and me. We have to be empowered through clear, honest disclosure of energy consumption. And finally, policymakers can step in and help strengthen regulations to make sustainability a core requirement, not just an afterthought. The good news is, the industry is already starting to move in this direction. We're seeing this exciting rise of smaller, highly efficient models, sometimes called small language models. They are designed from the ground up to be lean but still powerful, which just goes to show you that bigger isn't always better.
And this is where you come in. Really, by choosing products and services that are transparent about their energy footprint, you send a powerful signal to the entire market. Your demand for sustainability can actually push the whole industry to make efficiency a top priority.
Ultimately, as AI becomes more and more woven into the fabric of our lives, its greatest test isn't just going to be what it can create. The real test is how we choose to build it. We're standing at a fork in the road between unchecked growth and real sustainable innovation. The choice is in our hands.